Hi guys, so today we're going to be looking at 3.6 Quadratic Inequalities Part 1. So let's start off with graphing a quadratic quality in two variables. We're going to have three different steps involved. The first step here is step 1. We're asked to graph out the following equation, y equaling to ax squared plus bx plus c. When we create this graph, we're going to either be given a less than sign or a greater than sign, or a less than or equal to sign or a greater than equal to sign. If we're given a less than or greater than sign, then our line for the parabola is going to be dashed, like so. If we have a less than or equal to sign, our parabola is instead going to be a solid line all the way through. Once we do that, we also have to test out the point to see if it's a solution on the graph. So all I'm going to do is once I create my graph, I will pick out a ordered pair, such as the one right here, and I'll see if this is a solution or not to the graph. If it is a solution, then I plan on shading in this region, the region inside of the parabola. If, for example, it's not a solution, and let's say we have here no solution, that means that I will be shading in the region on the outside instead. Okay, so let's check out a problem. Right here, it's asking us to graph the quadratic inequality with two variables. And we have here graphing out y is less than negative x to the power 2 minus 2x minus 1. So first thing that I want to do here is I want to start off by graphing out the equation for negative x to the power 2 minus 2x minus 1. And we can use the ax squared plus bx plus c formula to help us find out what that graph would look like. So first thing that I want to do here, I want to find out what my axis of symmetry is. And to do that, all I need to do is use the formula negative b over 2a. And so we get here negative 2 over 2 times negative 1. And that just equals to being 2 over negative 2, which just equals to negative 1. Once I do that, I need to find out what my y value is so I can identify my vertex. So I'm just going to get the x equaling to negative 1 and plug it into my original equation, negative x squared minus 2x minus 1. When I do that, I get negative 1 to the power of 2 minus 2 times negative 1 minus 1. This turns into negative 1 plus 2 minus 1, and that equals to being just 0. So now that I know my x value and my y value, I can create my new vertex, which would be the x equaling to negative 1 and the y equaling to just being 0. So that will be the first point I plot onto my graph here on the right. So I'll plot out negative 1 going to left to 0. And then afterwards, if I wanted to find out the graph, I still need to find out a few points on this side of the graph and the few points on the right side of the graph. So I'll just start off by figuring out what the plot or what the point would be if x is equal to negative 2. So right here, I'll just solve for x equaling to negative 2. And I'll plug it into the original equation, negative x squared minus 2x minus 1. When I do that, I get negative 2 to the power of 2 minus 2 times negative 2 minus 1. And that equals to negative 4 plus 4 minus 1, which is just negative 1. So I get the order pair negative 2, comma, negative 1. So on the graph, I'll go 2 points to the left and 1 point down to negative 2, comma, negative 1. Next one that I'm going to be plotting out is x equaling to negative 3. And then from here, I get negative 3 squared minus 2 times negative 3 minus 1. That gives me negative 9 plus 6 minus 1, and that equals to negative 4. So my other order pair is negative 3, comma, negative 4. And I'll plot that one out too. Negative 3, so go to the left 1, 2, 3 points, and go all the way down to negative 4. Right over here. Once I have those points, just a reminder, whenever we know what our axis of symmetry is, which we know is at x equaling to negative 1, and we know this based off of our axis of symmetry that was found over here. We also know that this side is a mirror image of the side on the right too. So if the point that is to the left of the vertex goes all the way down to negative 1, that means that the point to the right of the vertex has to also go down to negative 1 as well. And the point that is 2 spaces to the left of the vertex goes all the way down to negative 4. And the point that is 2 spaces to the right also has to go all the way down to negative 4 as well. So right here, I get my parabola like this. And I'm going to keep it a dashed line because of the fact that when I look at my original equation, which is y being less than negative x to the power 2 minus 2x minus 1, we see here that we have a less than symbol. And we said that for less than symbols or greater than symbols without the equal to sign, we have to make sure that they're in a dashed format. If it was in a less than or equal to sign or greater than or equal to sign, then I would make it a solid line. But because we have just less than and greater than, gonna make sure that we have just less than symbol or the dash line. Okay, last thing is to identify the shaded region. So to do that, I need to pick a point either on the outside of the parabola, or I can pick a point in the inside of the parabola. Now pick the point inside of a parabola. It doesn't matter which one you choose, as long as you just choose one. So I'll choose negative 2, comma, negative 3. Okay, and I'll just erase the axis of symmetry because I don't really need it at the moment. Okay, so the axis of symmetry is negative 2, comma, negative 3. And we know that it's a point inside of the parabola. So let's figure out if this is a solution or not. If we have here negative 2, comma, negative 3, and I were to plug this into the inequality y being less than negative x squared minus 2x minus 1. When I plug that in, I get negative 3 less than negative 2 squared minus 2 times negative 2 minus 1. This becomes negative 3 less than negative 4 plus 4 minus 1, and we're left with negative 3 being less than negative 1. And since this is a true statement, that means that negative 2 comma negative 3 is a solution. And so I'm just going to highlight the area that's the solution, which is the area that's inside of the parabola. Done. Let's try out one more. In this case, let's look at two different inequalities. Graph the system of quadratic inequalities for y less than negative x squared plus 3 and y greater than or equal to x to the power of 2 minus 3. Okay. So, first thing I want to do, let's start off by graphing out y being less than negative x to the power of 2 plus 3. And I'm still going to use the formula ax squared plus bx plus c. If I were to overlap these two together, I just have to move my positive 3 to where the c's at. And because we don't have a b value, I'm just going to write down that we're adding by 0x. Because we do know that 0 times x, that just equals to 0. So at the end of the day, this is still the same as this equation here. And so my b value is going to equal to 0. A equals to negative 1. And c equals to positive 3. So I use my formula x equaling to negative b over 2a. And if I were to substitute the values in, I get negative 0 over 2 times negative 1. That would be just being 0. So now that my x equals to 0, I can plug that into my equation, negative x squared plus 3. And when I do that, I get negative 0 squared plus 3, and that just equals to positive 3. So my vertex has to be 0, comma, positive 3. Cool. And if I were to graph that out, that would be right here, 0, comma, 3. Next thing I'm going to do is just to find the vertex of the new equation, which is y being greater than or equal to x squared plus 2x minus 3. So from here, for x equaling to negative b over 2a, I get negative 2 over 2 times 1, that equals to negative 1. And then I'm just going to plug in x equaling to negative 1 into the equation, x squared plus 2x plus or minus 3. So I get negative 1 to the power of 2 plus 2 times negative 1 minus 3. That turns into 1 minus 2 minus 3, which is negative 4. So the vertex that I get here is negative 1, comma, positive, or negative 4. Cool. So I'll plug that out. Now use a different color. This will be negative 1 going all the way down to negative 4. So somehow these images are going to intersect with each other at some point. So let's start off with this point over here. I'm going to plot out 3 points to the right and 3 points to the left. So 3 points to the right of 0, comma, negative 3 If I went 1 point to the left, I would get -1. So let's plot out that one first. If we have here x equaling -1, that turns into being 4 negative x squared plus 3. We get -1 squared plus 3, which turns into -1 plus 3, and that equals to +2. So our new vertex would be -1, 2. -1 going up to 2. Okay. Second point would be 2 points to the left. So 1, 2. We could try out -2, see how that works. So when x equals to -2 for -x plus 3, when I plug that in, I get -2 to the power of 2 plus 3. And that equals to -4 plus 3, which is -1. So I get here -2, -1 is my next value. -2 going all the way to -1. And then I just need one more value. I'll choose x equaling to -3. When I do that for -x squared plus 3, I get -3 squared plus 3, which is -9 plus 3, that equals to -6. So I get my new vertex or order pair, -3, -6. Cool. So I'll plot that out too. And then once I do that, I'm going to just copy the other side. So we get -2, the other one is -1, the last one here is -6. And since this graph or this inequality is a less than symbol, that means that I have to create dashed lines again. They go all the way down. Same for the other side. Going all the way down. Okay. Okay. Then, last thing to do is to plot out a point for the equation. So I'll do that last. So first, let's do creating the line here. Okay, so I'm gonna graph out this point right here. So that means that I need to look at the point that's to the left of the graph, which is, actually, let's do the right instead. So the point to the right of the graph is 0. And 0 seems to be an easier number to graph out, so let's do that one first. So when x is equal to 0 for x squared plus 2x minus 3, we get as our new equation 0 squared plus 2 times 0 minus 3, and that equals to just 0 plus 0 minus 3, which is -3. So we know that our new order pair is 0, -3. So I'll graph that one first. 0 going all the way down to -3. And then let's point another graph. So x equaling to 1 for x squared plus 2x minus 3. I get 1 to the power of 2 plus 2 times 1 minus 3. That equals to 1 plus 2 minus 3, and that equals to 0. So my next order pair is 1, 0. 1, 0 would be located right here. And then the last point that's 3 spaces away from the graph is 1, 2, and 3. So it'd be +2. So when x equals to 2, for x squared plus 2x minus 3, I get 2 squared plus 2 times 2 minus 3. And that equals to just being, let's see, that would be 4 plus 4 minus 3 equals to being positive 5. So we get here 2, 5 as our last point. 2, all the way to positive 5. Okay, so if I have that drawing, I'm going to draw a solid line. And the reason why it's solid is because we have here y being greater than equal to x squared plus 2x plus minus 3. So because it's greater than or equal to, I have to draw a solid line instead. And you do the same points on the other side. Right here, and the last one should be right here. Okay. Cool. Last step is to identify the shaded regions. So if I'm finding shaded regions, I'll pick a point, and I'll start off by looking at my red function here and see if it's a shaded in center or if it's not. I could choose this point, 0, 0. That would be easy. I could also use 0, 0 for my blue area too and see if that's in the inside as well. So let's start off first with 0, 0. When we use the equation, negative x squared plus 3, and I still need the y, so my y is less than it. So this turns into 0 being less than negative 0 to the power 2 plus 3, and 0 is less than positive 3. So since this is a true statement, that means that my area for the red one is still going to be shaded in the inside. Okay. If I were to look at the blue value, then I can still use the same point and see if it's in the inside of the blue value. So right here, again, I'm going to make myself some space so you can see. We have here 0, 0, and I'm going to plug this into y being greater than or equal to x squared plus 2x minus 3. We get 0 is greater than or equal to 0 squared plus 2 times 0 minus 3. 0 is greater than or equal to negative 3. So again, this is a true statement, which means that my shaded region has to be in the inside as well, where 0, 0 is at. Done. So hopefully this helped. Good luck.